Welcome to Dam Engineering channel. In this video, we will see the uses of GeoStudio software and also run the seepage analysis for concrete dam. When we open the GeoStudio software, the first page appears like this. Here, you have the option of selecting new file or open the already existing files. Let us start with new file. Once you click the new file, this page appears. Here we can select the units. We will select the metric units and click Create. Once this step is over, we will this page. Here we have the options of Add, Summary and Settings. The type of analysis we can add from here. In the Summary dialog, we can add name of the project, author name. In the Settings, it is for unit system. By default SI units are set for the model. We can change this also if we want. Now we will see the options under Add. Here we can see 3D, 2D and other options. In the old versions of GeoStudio, these options were not there. However, most of the problems can be solved by 2D. We will try our problem with 2D here in this video. When we select 2D, this page appears. From this page, we can add further additions to our model. We all know that 2D problem means out of plane thickness is 1 meter, which is again shown here. In the Add option, we can see the capabilities of GeoStudio software. As we can see here, it carries slope stability, seepage analysis, stress analysis, earthquake analysis and so on. Now we see in detail of all these analysis. First is slope stability analysis. Here we can see it has 4 options. This can be done by limit equilibrium method separately, or the stresses from sigma analysis or quake analysis and work out the stability. In this screen we can see parent description. This means, sometimes for doing particular analysis, we have do other analysis first and then those results are used for the next analysis. Parent analysis results are used for particular analysis wherever required. Generally, seepage analysis results are used as parent analysis for stability analysis of dams. This because seepage analysis determines pore pressure or hydraulic conditions which are critical input for the stability analysis. In seepage analysis, we have 2 options. One is steady state and other is transient. Transient is used when we have rapid drawdown or sudden decrease in water from reservoir or problem under consideration. In sigma analysis, we have in situ analysis. That is, stresses are estimated in the in situ condition. Further deformation analysis, stress redistribution and consolidation analysis also can be carried out. In quake analysis, we can do equivalent linear dynamic analysis and nonlinear dynamic analysis. For both these analysis we should have proper material testing values to perfectly calculate or doing the analysis. Now, we will start with steady stage seepage analysis. As shown here, under seepage analysis, we have to select the steady state. This page appears. Here we can see the options. We can see the name, analysis type, physics, water and time. We can change the name if needed. Wherever not required, we keep the default settings. In this page, under physics, we are not going to change anything. When we click the water tab, we see following options. These options are very critical to obtain the correct results. Depending upon the problem, sometimes we might not get the convergence in the solution. Whenever we get such issues, these parameters needs review. We can refer to the software manual for the possible errors of convergence. Sometimes red cross errors will appear, which means that there is an issue with significant digits. Further, gray color circles also will appear during convergence issues. For that we have to review the minimum rate and number of iterations. These will be further discussed in detail in due course. Click Close. Upon clicking the Close, we see this screen. This is the main screen we actually work on. In any software, we should first know the different options available and what are their purpose. Left side we can see 2 mini tabs. One is for the sequence or analysis we are carrying out. Second one is Solve Manager, which is used for solving. Like in many softwares, File tab is used for saving, creating new file and so on. Here we can see import and export options as well. Generally, many softwares have the capacity to import the AutoCAD files for geometry creation. Further, the software files can also be exported as editable or workable AutoCAD files or other usable formats for better migration from one software to other software. Other tab is Define. Most of the important options are under this tab. When we want to create geometry by drawing, we can create points and create geometry. GeoStudio requires creation of regions. Every different material or layer is to be in the form of region. Regions can be directly drawn. Using points also, we can first mark the points and connect them to form regions. We can define material properties and boundary conditions and so on. Draw tab is having different utility. First, we have to define what we want. Further, we have to add using Draw tab. As we go in detail, we can see all these options in detail. We'll start with these problems. Here we can see concrete dam and foundation. It is always recommended to model the boundaries so large that they do not affect the model results. Generally, many model just dams. But wherever seepage or stability issues of foundation, we should also consider modeling foundations also. Here, we know that in concrete dams, seepage through concrete dam is very small, and our purpose is to check the foundation seepage or flow paths. If we want to check the seepage through the dam body, we can model the concrete dam with corresponding properties. Let's start our problem. We have to create this geometry. As explained, this geometry can be imported. We will develop this using points. This can be drawn directly using regions also. Here, we start with points. We have to input the points and the points will be showing like this. Once the points are created, they can be joined to form regions. Here, only the foundation is being modeled as geometry. Since we are not interested in seepage through concrete dam, we will be drawing lines to represent the concrete dam. This is because seepage through concrete will be very less. Only when poor quality concrete or joints between concrete blocks are defective, then we can see excessive seepage through concrete dam. So we will prepare regions now. Once regions are created, the next step is to define material properties. Once defining material properties, they have to be assigned. As we can see in the Draw Material tab, there are two options. We can assign material property and remove material property also. Coming to define material property, we can add as many properties as we want. Since we are now going with simple problem having only foundation, so we will create only one material as shown. In the material model, we can see saturated only. It has two options. Other is unsaturated and saturated option. Here, we assume that foundation is always saturated, so we are going with this. In the other option we have many properties to define. That will be explained in the embankment dam seepage analysis. Coming to values, we have to input conductivity, that is permeability value, saturated volumetric water content and compressibility. Now, we will define material and assign material to foundation. After assigning material properties, we have to assign boundary conditions. Procedure is similar again. By default, it has two boundary conditions. That is zero pressure and drainage boundary condition. Drainage boundary condition is just like filter, or whenever the seepage pressure exceeds atmospheric pressure, it releases the water. This is similar to functioning of sand filters or gravel filters, which we provide in dams to collect the water. Gravel big size materials are places on outer boundaries of embankment dam. In this step we create reservoir boundary condition with water up to full reservoir level and assign the boundary conditions. Further, we can check the mesh size also. After this we can solve the problem. Once the solving is completed, results will be shown. Here, we can add features to results. We can add potential drop contours, flow paths. We can also measure seepage at any location. This is how we can model and do the seepage analysis using GeoStudio software. Since this is concrete dam, we have not given any boundary condition at the base of dam. Blue color surface above foundation generally show the variation of total waterhead. We can see it decreases from full reservoir level to zero pressure at the end of dam.